Good morning. This is your stats sensei, Mr. Spensei, and this is the warm up on one sample proportions, hypothesis test, and confidence intervals. So, broccoli is best. A survey indicated that 80% of high school students expressed a preference for healthier food options over traditional ones. The Somerset cafeteria introduced a new menu featuring these healthier choices. After the healthier food had been served for 2 months, it seemed as if fewer then 80% of the students were choosing the healthier options. Scenario one, the student council decided to conduct a hypothesis test with a significance level of 0.01. So, okay, we have an alpha of 0.01. Go ahead and record that right here since we have that. Determine whether fewer than 80% of the students were eating from the healthy menu. Of the 1,100 students who eat at the cafeteria, 93 were randomly surveyed. It sounds like we have a sample size of 93, so I'm going to write that down. 68 of whom chose to eat from the healthy options. So it's 68 out of 93. So that 68 is our X. All right, so they wanted us to test this at 1% to see if whether fewer than 80%. Well, the claim was initially 80%, so that's our null hypothesis, HO. So P equals 0.80. I can go ahead and record that there. And then my alternative was they wanted to know whether it was fewer or less than 80%. So P is less than 0.80. All right, please remember these values will be the same and these values will be the same. The only thing that's going to change there is the inequality. So we need to figure out what P hat is. Well, P hat is going to be 68 over 93. And if I go to the calculator, I go 68 divided by 93. I end up getting 0.7311. So that's my p hat. All right. While I'm here, I'm going to go ahead and graph this because what we have is a claim of 0.80. This is p. We wanted less than. And sure enough, our p hat is right over here. And we came in at about 73%. And I'm just going to abbreviate it as 0.733. And remember, this goes to negative infinity and this goes up to positive infinity theoretically. All right, so we need to address our conditions, and that's why I'm doing this warm up because I was noticing that our conditions weren't looking too good. So everyone was doing a random sample because that's what it was. It was an assignment, so random sample. And it was a random sample of size 93, and that was given. We're doing pretty good with that one. We're also doing pretty good with the second one. We're all saying, well, n is 93, and we're going 93 times 10 and getting 930, and our population size was 1,100. So this is less than 10% of the population. So we can go ahead and sample without replacement. So that's pretty good. Where we're not doing well is here. All right. So first off, I want to remind people, and I'm going to write this up here, that our formula is Z equals P hat minus P over the square root of P times 1 minus P over N. So because this is P's here, we're going to need to use P's here. So we're going to need NP needs to be greater than 10. Awesome. So here's what I need to see. I need to see my sample size, which is 93, times 10. Oh, excuse me. 93 times P, which is 0.80. Rewrite that 0.80. And we're going to multiply that out. 93 times 0.8. And we get 74.4. equals 74.4. And I need to see that that is greater than 10. So I need to see this multiplication take place. The other thing is, and we're going to need to go n times 1 minus p is greater than 10. So in this case, 93 times 1 minus 0.80, let's see what that equals. So once again, 93 times parenthesis 1 minus 0.80, close those parentheses, and we get 18.6. And 18.6 is greater than 10, so our sample size is large enough. So that's what I need to see those numbers. Please make sure that gets shown. All right, we're going to go ahead and run this even though we're skipping steps and just make sure that we know how to do this. Stat test, and we're going to go to number 5, one proportion z-test. And we have a claim of 80%. We have an x of 68, an n of 93, and we wanted a less than. That's what our alternative hypothesis showed. And we ended up with a z of negative 1.659. And our p-value is 0.0485. Well, our p-value of 0.0485 is greater than alpha, so our decision is fail to reject. Now, if this had been at the 5% level, if alpha had been a 5%, we would have rejected. But since it's at the 1% level, our p-value is larger, so we're going to fail to reject. Okay, so we're going to go ahead and look at the next part, scenario 2, wanting to know the true proportion of students who were choosing to eat from the healthy options. The Somerset Council randomly selected 89. So we have a new sample size of 89 of the 1,100 who ate at the cafeteria and found that 56 of them were choosing to eat from the healthy food menu. Create a 96% confidence interval for the true population proportion of students from Somerset choosing to eat from the healthy menu option. All right, so p hat. Well, p hat's always x over n, so this is going to be 56 over 89. So let's figure out what that is. 56 divided by 89, and we end up with 0.6292. So based on this survey, we got a sample proportion or a sample estimate of 0.6292. All right, so we're going to go ahead and start writing our conditions for this. Well, 1, random sample of 89, and that was given. All right. Second thing, is it less than 10%? Well, n equals 89. 89 times 10 equals 890. And up here, we were told that our population size was 1,100. And same thing right here, 1,100. So that's less than 1,100. So we're less than 10%. So it's okay to sample without replacement. So we're good there. All right. So now we need to check our NP hats. Well, I want to remind us of what our formula is. Our formula is P hat plus or minus Z star P hat 1 minus P hat over N. Well, because we have P hats under the radical, that's what we're going to be using for our condition 3, which is our normality condition. All right. And that's different than the hypothesis test. On the hypothesis test, we were using NP. Here, we're going to be using NP hat. All right. So here's where the first two conditions everyone's been doing great with, but right here, we've been shortcutting it, and I don't want to see that. So that's why we're doing this. So NP hat. So in this case, we're going to go, all right, 89 times, oh, and this has to be greater than 10. NP hat must be greater than 10. I'm going to go ahead and rewrite that. n p hat greater than 10. And we have 89 times 0.6292. Well, I already know that this is going to be approximately 56, but let's go ahead and do that. So 89 times 0.6292. Oh, there it is, 56. Is approximately 56, and that's greater than 10. We check that off. But we need to check the one that really is going to matter is this one, n times 1 minus p hat. Has to be greater than 10. So it's going to be our sample size of 89 times 1 minus 0.6292. And wait till you see what happens here. 89 times parenthesis 1 minus 0.6292, close parenthesis. Oh, it's about 33. And if I add these two together, sure enough, I get to 89. So this is approximately 33, which is also greater than 10. So we've met our normality conditions. All right. Okay, so let's remind ourselves how to calculate Z star. We're going to have to go to inverse norm. It's going to ask for an area, which in this case is going to be 1 minus 0.96 divided by 2, and we'll need to use the left. So let's do that. Second vars, inverse norm. 1 minus 0.96 divided by 2. Mean is 0, standard deviation of 1, and it'll always be that. We wanted a left. And we're going to go ahead and make this thing positive because we're positive people. And we get a 2.0537. So 2.0537. And I'm going to go ahead and plug into this formula, p hat plus or minus z star. So p hat, in this case, is 0.6292. 0.6292 plus or minus z star, 2.0537. Times p hat, 0.6292. 0.6292 times 1 minus 0.6292 all over my sample size of 89. So let's go ahead and run that real quickly and get our interval. So stat test 1 proportion z interval. That's going to be letter A. So we're going to have to scroll down a little bit. There it is, 1 proportion z interval. And we have a 56. We have an 89. And our confidence level is 0.96. And we believe the true proportion is really between 52% and 73%. So our interval is approximately 0.5240 and 0.7343. All right. Well, I hope that helped on the warm up, and let's get those conditions right. Thank you. See you on the next one.